Hey everyone. In this video, I'm going to just show some incremental updates I've been making to this board here. If you're more interested in the bigger jumps of updates and functionality, you might want to skip this video. But for those of you that like to see just the small changes I'm making as I go, this video is probably for you. I'm going to point out a few things on the hardware side and a few things on the toolchain side that I've changed since the last video. And again, as a reminder, I'm new to all the FPGA stuff, especially the Lattice. I have done some ARTI type of stuff, the Digilent ARTI way back when. That was probably a couple years ago, 2 or 3 years ago. But other than that, I haven't done much with FPGAs. And I definitely have not done anything with the Lattice toolchain and hardware here. So kind of learning my way through that. On this version of the board, what you're going to notice is I swapped the functionality of these two ports. I moved the binary counter from this port to over here and the sweep from this port to over here. Not a big deal. I just wanted to see this horizontal version of the counter. So this binary counter, I wanted to see it like this because that visually is easier for me to look at than to look at it over here. But really not a big deal. Just a couple of quick pin addresses being changed in my code. Something else I've done is I've added in a few more headers. And I would say that as I've added those headers and I want to quickly test them, I'm just putting in the same code that's going to this port over here, writing that out to these ports, and then pulling off, one of these LED headers and placing it over here. And that's a really quick way to see if it sweeps through all of the 8 bits on that port, because there's 8. I have 8 bits or 8 GPIO I/O pins coming from the FPGA on every one of these. So it's a really quick test. And I did find that on one of these, it was missing a couple of LEDs as it was strobing its way across. And I tracked that back to just a couple poor connections on the solder on the legs of this QFP here. Other things that I've done on the back side of this, I did fill in the remainder of the capacitors. Now, to note, this version I had probably double, if not triple, the number of 4.7 microfarad capacitors that I really need. So there's a lot more capacitors here than I actually needed. And that's because I misread the spec. And the spec was saying, well, for every pin, every power pin, basically, there should be a 0.1 microfarad cap. And then for every different type of rail, basically for each of the I/O rails or whatever it might be, or VCC or other like the SPI power, there should be a singular 4.7 microfarad cap. And I ended up doing one 4.7 cap for every pin instead of every rail. So I've got too many of those. But in the BGA version of the board that's coming, I did clean that up. I reduced the number of those. But since I had them in my schematic, I just figured I would just place them, and I did that real quickly here. So I should have plenty of capacitance to support this here. Something else I did come over here to this oscillator, and I put in a 100 megahertz oscillator. So that's what's running at the moment. And I have modified the code to not trigger as often because this is a pretty fast clock. I went from a 60 to a 100, and then I just slowed down how often really the code fires to update these LEDs. Something I did on the toolchain, if I switch over to that on my screen here for a second, I did go in and switch my code from VHDL to Verilog. So when I open up my code here, I am going to do Verilog, not System Verilog yet, just plain old Verilog. And I did set it up so that I'm using Visual Studio Code for my editor. And that's what you're seeing here. So that, this is the main module that I'm using. And so I've got some code in here that I'll talk through in just a little bit. And I do have multiple files now. So there is a primary file I'm using, which is this TQ144 testing. And then I am also using a nibble to 7 segment LED module that I put in here. I also put in a binary to BCD, but I'm not using that yet. In addition to this, I did come in here. Let me go back to a couple of files. In this project, this is one of my source code files, and it looks like this, and I'll come back to that. But then I also came in down to my constraints, and if I look at the updated constraints, I do still have my clock on pin 20 that is coming in, and then I have the previous output LED, basically these two ports, those outputs. I swapped the pin numbers around, or the names, so LEDs and LEDs 2, I just swapped those. That was what gave me that result. And then I did connect in two more ports, these two ports down here, and I labeled those 7-segment. And so I have a 7-segment basically for a left and a right digit. And I'm going to show that here, that I've got a 7-segment to show on this port and another 7-segment to show on this port here. I also came back into another file in here, and I'm going to come down here and look at, let me grab where it's at here, constraint files up here. This is under synthesis tools and constraint files, but I added a constraint file up here that specifies my clock. So I create a clock and I give it the period, and this is the period that equates to a 100 megahertz clock. And so this period, I believe, is in nanoseconds. And so 10 nanoseconds is my period, which is 100 megahertz. And I could probably just test that real quick, or make sure I've got that right. Convert nanoseconds to megahertz. And looks like there's a tool here, but let's just put in 100 megahertz and convert that, and that's my 10 nanoseconds. So that's what I put in here, is 10 nanoseconds for my period, and just said that the signal called I_clock is basically going to be my 100 megahertz. Now that will come in later when I start looking at some of the timing analysis, which I've been trying to learn a bit more about in this tool set. But it'll shoot for 100 megahertz, and I'm telling it that's what I want to be using, and then it'll tell me if it fails to meet timing requirements at that speed. So something else I then did, let me turn this off, is I put together this little board, and I just have a bunch of these little, makeshift PCB type of build out prototype boards around. And so I just put a header on the bottom, and this header will connect to a pair of these. So it's just basically one solid header that connects on. And then beside it, I have a pair of 7-segment LED displays. And this is just wired up accordingly. Nothing real fancy here. I didn't want to order up PCBs just to do this. I thought I would test this and kind of give this a shot. And basically what's going to come in from these signals is not the ground. I'm not going to use the ground here. I'm really only pulling pins to the FPGA that are going to connect to each of the segments on here. And I'm not going to supply power coming down through this. It's actually going to be the other way around. When I pull one of these pins low, I'm actually going to pull power in from this pin through that segment, through ground back up to the FPGA. And on my computer screen here, I have the schematic of the one I'm using. Now, as I was getting into this, I was referencing content here from NANDland, and this has been a great little website. And the gentleman that put this together, I've watched a bunch of his, they would have been VHDL courses on the Xilinx platform a couple of years ago, and I thought those were all great. And then I stumbled across this NANDland, which I think has been there a long time. But there's a book, and actually he's got his own little FPGA here, just a simple one for learning. And if I can get it out of the package, it just looks something like this. So I did order up one of his Go boards just so that I could kind of play around with that and see what I could learn from this board as I'm going, because a lot of things I want to be doing, especially the VGA output. So I'll be interested to learn the VHDL or Verilog on that. But on his website, he got into this idea of using one of these types of displays, and I did pull up the spec for the one I'm using. So I'm using this specific a 7-segment display here. But what you'll see is that each of these segments, there are basically pins on the bottom. So I've got a total of, 16 pins on this. So there's 8 along the bottom, and then it wraps around 9 through 16. And then in the schematic on the computer here, or in this data sheet, I should say, it does show that, okay, I'm going to bring in a single power into all the LEDs and then bring pin 15, for example, to ground to actually light up that segment. This would be the A segment on the left digit, which would be right up here. So A, B, C, D, E, F, and G. So that's the listing of the segments. This is just showing I bring in a single power, and whichever ones I pull to ground are going to be the ones that light up. Well, I'm going to pull those to ground basically through the FPGA. So I'll go ahead and put this board on, and let me just do that quickly. And then I need to connect the power to a 3.3 volt positive. So I'm going to bring 3.3 volt in. I think I could bring 5 volt in too, because it's going to drop enough before it comes back to my FPGA, but I'll do 3.3 volt here. So 3.3 volt is coming in, and that's coming into this pin 4 and pin 5 that you see on the computer. And then all of those other pins on the bottom, all of these, which would be, 14 pins there, are going to 14 pins on 2 different ports that I've configured. So I'm not using 1 pin on each of the underlying ports, which is fine. But then I have something like this. And if I turn this on, what you're going to see is that I'm going to display in hex the same value as what's showing up on this binary counter. And hopefully that will come across okay on the lighting that I'm looking at. But basically on the video, I'm counting my way up there. I'm at 40 and I'm working my way up, and you'll see it's going through the A, B, C, D, E, F and to the 5. You'll go all the way up to FF, and then it will drop down back down to 0 and kind of start over. And so I'll let that run, and you'll see that when this bank up here is completely lit up, this will be at FF is what I should be seeing for the output on that. And I'm hoping that that comes through okay on the lighting, but we'll see. Now to do that, if I jump over to my project for a second, here is the main module. Now I did find that as I added multiple files here, I did have to come in and tell the system which file was my top module, or the main module. And to do that, I'll just show you that real quickly. I have to go to Tools, Tool Options, and there is a Simplify Options. And then that pulls up this. And I'll say OK to the tooltip. But then from here, I can go to Options, and there's Verilog compiler options, and I had to plug in the name of my top level module. So I put that in there in this separate tool, which I've not done anything in this tool yet other than that. So I might have to come back and learn more about this tool as time permits. But that's the tool that must be, or is being used down here, I guess, when I go ahead and I double click and I say, build that or run the synthesis on it. And then that will run this, and I should see this come back very shortly with a succeed. So that succeeded. Maybe something else while I'm here, I can also look at timing options or timing information. Now some of that, of course, kicks out here in this output. For example, I can come over here and say, okay, I was requesting a frequency of 100 megahertz. And if I look at this, that it's saying, well, you can actually run at about 125 and still be fine with what I'm doing right now. And I think I can also come up to Tools, and there is Timing Analysis. Let's see what I need to do to pull that up. Let me build out this next piece, and I think, yeah, it's probably going to want me to do that. So let me come down here to Run, Place, and Route. And I think after I get done with that, I can go back up to that tools and take a look at that. And I'll do that here in just a second as this gets through this. Okay, so it is running router on the bottom. I can see clock summary here. 100 was my target. It's saying that 155 is achievable. Bitmap succeeded, so that all worked out fine. And then I can pull up this timing analysis. And that shows me the same thing. So my target frequency, this is what I had put in to that constraint file. And it's saying, well, the fastest I'm going to be able to go is about 156 for the oscillator. And I'm running the 100 right now, and it's perfectly good with that. If I go back to my code, though, what I have here so far then is, I'm bringing in the clock, and I'm not even using this anymore. I can probably take this out, this C done. One of the things that I found, I want to be able to come down here and do something as simple as just have this LED sweep. And I've had to stick with this case statement. And I found that these FPGAs from Lattice, you cannot set a default value to the register. So I can't set an initial value to a register. That they don't support that. So then it seems like I have to then put in some implementation around a reset signal. And then in the reset signal, initialize my values. And I've not had any luck getting that done yet. So I'll have to keep digging into that and see what I can figure out. And I actually see I've got a bunch of code here I don't even need anymore. So I'm going to take some of this out. This was temporary code I had put in earlier, but I'll take that out for now. So I've got a clock. I have 4 outputs, and these would be basically those 4 ports. And each of these is 8, basically 8 signals. So I've got these 2 8 ports, and then I've got 2 8 ports that are controlling these 2 7-segment characters. I am telling it how high it should count before it gets to, the delay in which I want it to actually make a change here. And so I've increased that number probably 5-fold from the last video. And I am running obviously a much faster oscillator, going from 60 megahertz to 100 megahertz. But then once I get in here, I'm just simply incrementing this R LEDs. So that would be one of these registers, and I'm just incrementing it, and that's essentially what I put out here. And then if I keep going down, here's the code that is simply checking where is the bit at, and actually here's my incrementing one now that I moved it, but here's the one that's just simply sweeping with this case statement here. So the addition here is what I'm adding to this port, and then this other one with the case is what's sweeping up through that. And then I put in calls to a couple other pieces of Verilog code in this other file. And I have another file that's called nibble to 7seg. So I took a file from Nanland, which is where I downloaded it. I just renamed it to a slightly different name. I called it nibble because it's half a byte or 4 bits that I'm converting to a 7-segment output. But that's all this is doing. I modified his version just with the name, and then I'm also returning an inverted because of how this is working. It's actually, when I want to light it up, I need it to be going to ground down, in other words, a 0 instead of a 1. So I inverted with this tilde here that is doing the inversion. But this is basically saying, okay, send in 4 bits, and it'll send back basically a pattern that'll tell me which of these LEDs to light up, which of those segments. And so I do that both for the left, which is this digit left, and the digit right. And I don't use the last bit in those 8 bits. That's why I go from 7 down to 1, because the 0 bit is not being used because there's only 7 segments. There aren't 8 segments, and that's how I chose to set that up. And again, I can go back over to this file and see specifically which pins is that mapped to. I can also come over here, and there is there are some things I can look at, I guess, on output. There is a report, and I can look at, how are oh, let's just say my pins being set up. And so there's a CSV version of that I can go look at and kind of see what does the output look like. And it puts it in an Excel file, or for me, an Excel file. It's just a CSV file, which is kind of handy. I can also come in here and look at package view, and this will show me, where these pins are coming from. So I can see that I have, first of all, this right digit. And if I look at that, I can see as I'm clicking these, if you look at the lower right down here, it's showing which of these pins. So basically I'm going from this pin and I'm working my way over and pulling each of those pins. And if I get down to the digit left, you can see here as I cycle through those, and basically that's all the bottom bank. And then if I look at this LEDs up here, you can see that's in the top bank in the upper left. And this other one is over here on the right bank. So I'm pulling from 3 of the banks there. And the only thing I'm using on the left bank is I'm bringing in my clock. So that would be this here. And C done, that'll disappear here. What I was thinking I might do is put something on looking at when C done goes high and then initializing my values, but that didn't seem quite right. And I didn't get that figured out. So more to come on that. I think there was also a power estimator here, and I've not done anything with this yet, but maybe this is just showing, letting me set my core VDD, which is, I'm doing 1.2, I'm doing 3.3 for all my IO, and it looks like there's a calculate, and that must be getting into some of this over here. Now, you do see on here, it's showing that it's about 1/4 of an amp, 220 milliwatts is what milliamps, sorry, 220 milliamps that I'm using right now. And looking at my actual power supply, which is probably a little bit more accurate, it's fluctuating between 0.25 and 0.23. So I can tell this is about 20 100ths, 20 thousandths off. Yeah, that'd be right, 20 thousandths off. But anyways, this is just showing you, giving you an idea. It's relatively close, or close enough, I guess, as I'm getting into this. So maybe right now, if I have made these changes, so again, I did go back to this and I took out the C done because I didn't need that. I commented out, and actually I'll just delete all of this. This was just temporary test code. So that's all out of there. I'll save that. I did update this file here. Let's see. Okay, maybe nothing's changed there other than I might have had, let's see, did I have, no, I didn't have the reset pin in there, so that should be about it. So I can come over here now and rerun this synthesis. So let me do that. And I don't expect any problems with that. And then once that is done, I'm going to go ahead and start the PNR down here by double-clicking the Run PNR. And while it's doing that, I'm going to go ahead and flip over. I'm still using this Diamond Programmer, which has been working fine. So I'm going to turn off this, so no power coming to this. I'm going to go ahead and plug in my programmer header here and just get that on here like so. And in the background, I can see it's still working through its stuff. But at this point, I know it's going to finish pretty soon. It's running bitmap. Bitmap succeeded down here. So it's done building that bitmap. I can apply power to my board. And this programmer shows that I have power, again, to the USB and the board. So then I can just come in here and say program. And really the only thing I've done is I pulled out a couple of things. So I don't expect this to have broken anything. So that, if you did see there was a quick error that rolled by down here, that was just saying that the source file changed, which it did because I rebuilt it. So that completed successfully. I'll turn this off, disconnect this, and then I'll fire this back up and off it goes. So I think that's all I had for today. I'm going to keep working through some of the stuff that's on this website over here, NAND Land, because there are some, the Go board. This is that board I was just showing here for a second. If I bring that back on, so I've got that I can work with, and he's put a bunch of nice tutorials up here, talks through it. There's videos to go with all of it. So I'm kind of just working my way through a bunch of those. I also have over here too, I did grab, this is Lattice's board. I think it's just, they kind of call it a breakout board, but it's for the HX8K. So this is the, I think the most capable one that they have. And then it looks like they've just given a ton of pins for breakout and whatever the headers. And they have the built-in USB programmer right here too that I can use. So, I'll probably look at that and learn from that. I'll look at this little version of the Go board and probably learn some stuff from that. It kind of is a cool little board. So if you're looking for an actual board to start learning some of this stuff, it seems like this is a pretty cool board. I haven't used it yet, but I will be playing with it pretty soon. And just the content that goes with it is great up on that website. But on my board here, probably what I need to do is test out, some of these voltage levelers. I have not put those on yet. So maybe I'll get one of those on. I kind of need to keep learning some of this Verilog so that I can do something that's maybe bi-directional as far as input-output. I'm sure I could do something simple with LEDs or buttons, but it'd be nice to do something more than that. So I might do that with maybe if I can get to the point where I can do like a 1602 LCD, so a 2-line, 16 character per line type of standard LCD that you've seen on countless projects of mine. Maybe I can get one of those connected up here and go through the, isn't even necessary, but I could go through the 5-volt stuff just to do the leveling. And maybe also get the support to read back the status from the LCD so I can test the two-way communication there. I think I'm a little ways from doing anything with static RAM yet, but I will eventually get to that. And I think that's about it. That'll get me close to, testing different things on this board, and I just have a lot of time to invest to learn the Verilog side of it. Toolchain wise, things are coming along fine. It seems like this iCE40 2 is still working well for me. The Visual Studio Code I'm liking as an editor. The Lattice programmer is working fine. And, even the power rails I have here are working fine. I don't know if that'll change as I add more stuff. But again, these 3 power rails are all powering on. Well, they're all receiving their input at the same time, and maybe I would guess that the 1.2 just naturally comes up faster than the 3.3 or the 2.5, but not had any problems with power at this point. And I am, pulling probably power from these ports that probably isn't recommended to do that. To drive LEDs, but like I commented last time, I think these LEDs take so little power, it's really not a big deal. I do notice more power being drawn overall, definitely as I added these 7 segments here. And I will comment, I didn't place any inline resistors here. I'm basically just treating the LED as good enough, because this is only 3.3 volts. So even if that came all the way through directly to the FPGA, I don't think that would be a concern. And I could probably make this a bit brighter if I went over to the 5-volt header, and it probably drops a couple volts, so 3 would come back over here. Anyways, if I'm understanding how that's all working correctly. But that's it. And like I said, I think I have the BGA version of this, the smaller BGA version, showing up here sometime next week. So maybe next weekend, I'll see if I can't have some results, good or bad, on trying to get the power up and running on that board, because that's a little bit more complicated power setup. And if I'm successful with that, maybe the following week, I will try to actually solder in the BGA and see if I have any luck with that or not. But that's it for now. Thanks for watching.